Hey everyone, so I just wanted to go over the quiz review with you so that if you have any questions or get stuck, you can look through and sort of scroll down and see my explanation for some of these problems. This will be very similar to your quiz. That's also kind of just a general overview of the actual unit that we've been talking about. Anyway, write out in words the equation for speed. Um, Well, we know that just the equation is speed equals distance divided by time. So you could look in your notebook. It's the rate, because remember, divided by time means rate. So the rate at which distance changes is one way to word it. Distance changes. That's one way to word it. You can word it in a couple different other ways, but for me, that looks pretty good. You can go with the definition given in the notes, but just in general, pretty simple. Write out in words the equation for displacement. Remember that displacement is the straight line distance between starting and ending points. So we've touched just a little bit on the idea of position. Really not an important equation. The final position, if x is position minus the initial position. But in words, what we would really say is, as we put it, the straight line distance. This pen is a little hard to write with. Between start and end points. And end points. And the key main thing that you absolutely must have is with direction. You need that direction. It could be up, down, north, south, left, right. It could even just be simple as a plus or a minus. Those also tell you direction, but you need something with direction. Kind of redundant, identify the difference between displacement and distance. Diagram's always helpful. Well, so if this is where we start, and this is where we end, our displacement would be, let's say that that's 5 meters. Our displacement would be 5 meters, and you could say it one of two ways. You could say on the paper just to the right. You could say 5 meters east, assuming that that's east, whatever. And distance, thicker line here, you can take a bunch of different paths, still end up at the same spot. So our distance might be, let's say in that one, maybe looks like it's about 15 meters. Displacement has direction, distance does not. Okay, so that's pretty good. Let me clear this. Move on to question 4. Which term correctly represents, terms correctly represents a velocity? Well, velocity is displacement over time. Displacement has direction, so velocity has direction. I look at things that have direction. That's got direction, and be careful, because remember, from just above, that plus also is direction. This one has no direction. I know that C is automatically out. Alright, so let's look at these. We got to now look at the units. Meters per second. So you have a length divided by a time. A is definitely a possibility. What about B? 5.1 meters per second. There's that meters per second again. North, we got the direction, we got the units right. B could definitely be a velocity. And 5.1 centimeters per hour, different units here. Centimeters, still the unit of length. Hours, still a unit of time. And we've got southeast. It's like a double direction, but we've talked about that in class. So D is also a velocity. The only one that wasn't was C because it had no direction. Slope of a distance time graph at any point. Distance time graph. At any point when you have a slope that is rise over run, so the slope is distance over time, and look, distance over time is speed, so speed is true. I'm going to be a little picky, and if you put speed, perfect. But also, remember we have that plus or minus going on, so there's a difference between a slope like this and a slope like this, so you can also get velocity from a distance time graph. This one would be like -3 meters per second for speed, or sorry, for velocity. This one would be positive, maybe 3 meters per second. That positive, that negative tell you the direction. It gives you that velocity. Cool. Scrolling up a little bit more. If a car travels a distance of 359 meters over the course of 45 seconds, what is the average speed in meters per second and miles per hour? So I need to convert some things. So, average speed. Speed is distance over time. They're going 359 meters per 45 seconds. So type that into my calculator. 359 divided by 45. And right away I have 7.98 meters per second. So the meters per second's done. I've got to turn it to miles per hour. 7.98 meters per second to miles per hour. Deal with the hours first. I know that seconds is on the bottom, so seconds have to be on top. We've done it enough that I can do the conversion right from seconds to hours. There are 3,600 seconds in 1 hour. Seconds cancel. Meters per hour, I want miles. So meters on top, meters on bottom, miles on top, so that meters cancels with meters, and I know that in 1 mile there is 1,609 meters. So, I'm left with miles per hour, which is what I'm looking for. 7.98 times 3,600, which is the top. 28728 divided by everything on the bottom, 1609, and I'm just showing one extra step. You don't have to show that step. Divided by 1609, I'm going to get 7.98 meters per second and 17.85 miles per hour. Those are my two answers. Number 7. If I walk to the east for 20 minutes at 7 meters per second, abruptly turn around, walk west. Okay, so this is kind of a difficult problem. It's just lengthy. We've got help. It always helps me to draw a map. So 20 minutes, 7 meters per second. So already, right away, I see minutes and I see seconds. And I say, that's no good. So I have to change one to the other. Doesn't matter which. I think it's easier to change minutes into seconds. So I'm up here or wherever you want. I'm going to change 20 minutes. 20 minutes in 1 minute. There are 60 seconds. Minutes cancel. So that's 1,200 seconds. So my first spot. Here's my start. I don't know what I'm doing yet, but I know that I'm going to go this way to the east. And the distance east, I'm going to deal with the 1,200 seconds times 7 meters per second. My distance of part 1 is 1,200 seconds times 7 meters per second. That conversion idea still works. Seconds cancels with seconds, so I'm going to be left with meters. So that's perfect. 1,200 times 7. I go 8,400 meters east. This is just my part 1, so the distance would be 8,400 meters. The displacement east, the displacement for the first one would be east. But then I turn around right away and walk west for 3 minutes at 400 meters per minute. So I've got minutes and minutes. I'm okay with the unit on this one, unlike the first part. I'm going to the west, so I'm going to go, my distance is my speed times time, and it is 400, doesn't matter which order I put them in, meters per minute times 3 minutes. Again, minutes will cancel with minutes. I'll be left with meters. So that's 1,200 meters west. So just a quick drawing to help me see. I go 8,400 this way, abruptly turn around, come back less, 1,200 that way. So average speed is my total distance divided by my total time. Well, let's see. My total distance doesn't matter the direction, so I'm going to add them up. 8,400 plus 1,200 is 9,600. So my average speed is 9,600 meters divided by seconds. Just meters per second is more what we're used to. So I do have to do one conversion here. If I wanted to do it in minutes, I could just divide by 23 and have meters per minute. It doesn't say I have to put it in one or the other, so that would be fine. But I'm going to do it in seconds just because I like seconds. So 3 minutes, I know right off the top of my head that 3 minutes is 180 seconds. So I had 1,200 seconds and 180 seconds. That's 1,380. So 1,380 seconds, which gives me a speed 9,600 over 1,380. Gives me an average speed of 6.96 meters per second. And my average velocity, ignore this, I'll come back in a second. My average velocity is going to be v equals displacement over time. My displacement is my straight line from start right to finish, so I have to look at those two arrows and subtract them. So 8,400 to the right, 1,200 back. The 1,200 cancels part of it, so I'm going to subtract 8,400 minus 1,200, and I'm going to get 7,200 meters. But more than that, displacement needs that direction. I went more east than I did west, so I have east as my direction, divided by the same time, 1,380 seconds. And then simply divide 7,200 over 1,380, gives me an average velocity of 5.22 meters per second. Velocity needs direction, so east. There's my average velocity, there's my average speed. Thinking about thinking, I'm checking. Speed has to be greater or less than velocity. Speed of 6.96, velocity 5.22, which makes sense. Perfect. All right, I'm going to continue the rest of the equation or rest of the problems on the next screencast. So this will go 1 through 7. All right.